one. Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer here at The Construct. My name is Rodrigo and today we have one of our students, Shivesh, who has completed one of our courses, ROS 2 Basics in 5 days. And at the end of this course, you can take a final project and apply it on a real robot in order to solidify your learning. So that's what we're going to be seeing today from our student, Shivesh. Hello, Shivesh. How are you?
I'm good, Rodrigo. How are you?
I'm good. Thank you. Thank you very well as well. So yes, whenever you want, you can start sharing your screen and show us how you've done your project.
Yes.
Great. All right, we
So,
can see your screen now.
yeah. So right now, I think like you can see my screen
Mm-hmm.
and yeah, this is the robot camera and I'll get my terminal on. So yeah. So as you can see that my ROS2 environment has been already been set up
Mm-hmm.
and I think this camera is still taking some time to load, but I think like this camera enough is like right now is enough.
Yeah, we can work with the other one for now.
Yeah. So right now I'll just start like launching my code and keep explaining from there on.
Great.
Yes. Oh,
Oh, you
so
can see
somebody
some
left.
people
Yeah.
running around. So you can see
So
it's a live environment.
I like started running my program. Right now the robot is searching for the closest wall. And yeah, after finding the closest wall, it goes a little bit behind in the optimal range. From there, it again turns left in order so that the right hand side of the robot is always parallel towards the wall.
Uh-huh.
And from there, the robot will start its wall following function. So yeah, as you can see, the robot has already like started to move, and it is basically using two parts: the front laser and as well as the side laser, or should I say the front right side of the laser. This is because like the robot detects a wall. The front laser basically it is used for corners because if it detects the wall in front of it, it will
Mm-hmm.
automatically turn left. Whereas the right hand side of the laser is basically so that it is always parallel towards the wall on its right hand side and it remains in the optimal range.
I understand.
Yes. So yeah, as you can see that it has like done like two corners right now.
Mm-hmm.
Usually I'm a bit nervous in the corners because sometimes it might just like hit it or
Yeah. Do you mind stretching that out a little bit since we don't have that one camera? Do you mind making that a little bigger so we can see a little more? That's perfect. Maybe we can put the term. Oh, awesome. Perfect. That's great. So we can see the actual movement here. It's almost ready to. Oh, looks like it finished, right?
yes. So as soon as it finishes a lap, it automatically stops.
Mm-hmm.
So basically, I'll just kill the node over here right now because it is still continuously recording the its odometry
Okay,
uh,
I see.
positions. Yeah.
Awesome.
So
So perfect. It did the project at the first try.
yeah,
No issues. So if you could just explain how you did each section now, that would be great.
sure. Yeah, I'll just quickly explain the my terminal readings.
Great.
These are basically the geometric positions of the robot that it has encountered throughout the lab. So these are the X, Y, and Z positions.
Uh-huh.
And yeah, and you can see that the total distance traveled by the robot is around 6.08 units. So it should be around that range between 5.5 and 6.
Mm-hmm.
And because the robot does not really go straight, it like swerves left and right. So there's a little bit of extra
Extra
distance.
distance.
Yes, yes. So yeah, I think like this is about it. These are the main two things that I wanted to mention in the terminal: the geometric messages and the
And then this list,
position.
which is the result, right? Of
Yes,
your
yes, sir.
action. Great.
So yeah, I have a presentation to show it to you. So can I
Awesome.
start?
Yes, please go ahead.
Yes. Yeah. Okay. Wait.
Don't worry.
Yeah. Yes. So
I
yeah,
can
this
see
might.
it now. ROS 2 Basics in 5 days. Yes.
Yes, so yeah, this is my ROS2 basics in 5 days Python presentation. And yeah, basically like the contents of this presentation is, it is basically divided into three different sections as per the project itself. The first section is the topics, the second is the services, and the third is the actions. And as you can see, the topics is basically used for the wall following behavior, and the services part we have used for the wall finder and the alignment part, which is the section 2, and the section 3 is basically actions, which is used for the odometry recording. And yeah, so basically, this is the current like existing environment of a robot. It is basically a rectangular room surrounded by the walls, and we are using a Turtlebot 3, which has a 360-degree LiDAR reading. And yeah, this is basically an image of the robot that we are using. And this, the green zone, I'll say, is the optimal zone of the robot where it
Mm.
should be there. And the red part is the wall where like it should not, it should keep the wall in parallel towards its right hand side.
Mm-hmm.
And the blue line, I've given it so that it is basically the movement of the robot. I know that it does not really go straight. It swerves like a little bit like a snake, but yeah. So
Mm-hmm.
basically, yeah, so basically the robot should just come back into the green optimal zone, whether it's going towards right or towards the left hand side. Yeah, so I'll go to the next slide. So yeah, basically like the topics, over here we are using the laser scan data utilization. So as I mentioned during the simulation, it is using basically the two parts of the laser, the front and the right hand side of the robot. Because like in the simulation, the real robot, there were some differences
Yes.
which I encountered. Yeah, and so basically, yeah, the logic behind adjusting the velocities. When the front and the side distance is too large, the robot will move forward with a small linear velocity, and it turns right with the angular velocity that I've given to, so that in order the robot to get closer to the wall, and it should be in the green zone actually,
Yeah.
that I mentioned in the previous slide. So yeah, and when the robot is basically within the green zone, the I set the angular velocity to 0 and the only the linear velocity, so that it moves straight, because it's in the perfect zone. And again, yeah, and when the robot is actually the distance too small, that means when the robot is actually too close to the wall, the robot should slow down and it should move left. And accordingly, I've given the angular velocity and reduce the linear velocity. And yeah, and yeah, this is basically the flow chart or the algorithm that our wall follower is following.
Oh, nice.
As you can see that this is our wall follower program, and basically it is subscribing to the laser scan topic over here. The laser callback is subscribing to this topic. From here, it gets the readings of the environment using the laser, basically the walls and the other obstacles. And over here, this is the motion function that I've defined in our program. Basically, like that, have the logic that I've explained before in the previous slide.
Yeah.
Yeah. After it follows that logic, and the publisher uses this logic to publish it using the command well topic, which is basically used to control the robot's movement. This topic is used for that. And yeah, so basically this is the summary of our wall following program. So I'll go to the next slide. So yeah, this is basically the services part, which is the section 2. So so we are using services over here basically to find the wall, which was the second part, to find the wall and to go to the optimal distance from to the wall, and from there again like orient like the make the robot orient in such a way that it comes to the green zone, aligns itself, and makes sure that the right hand side of the robot is always parallel towards the wall. So yeah, as you can see, like I mentioned here, the robot like continuously adjusts its orientation until it aligns with the predefined angle, which is the front laser, of course, ensuring that it is facing toward the desired direction. And the robot adjusts its position forward or backward until it reaches a predefined distance from the detected obstacle. And this distance, 0.3 meters, I got it from the project. It was mentioned over there. And yeah, and aligning the final orientation that I've already mentioned, the robot like continuously adjusts its orientation until the robot aligns its final orientation to face another predefined angle, which is basically the right hand side of the wall
Mm-hmm.
robot. Yeah. So yeah, from there, like once the service is done, it is the basically the service finishes, and from there the wall following program takes over. And throughout these steps, the robot will it publishes the linear and the angular velocity to rotate itself. And yeah, this is basically the services part.
Mm-hmm.
And yeah, we have the flow diagram. I usually do this because
This is
visualizing.
awesome. Where did you make
Yeah.
these?
Yeah, these are basically I use like what do you call that PowerPoint itself. Like I use like square and circles because it's easier.
Oh, well,
I know there's also a function like I think it's graphing function in the nodes.
yeah.
Yeah,
Well,
yeah,
I
but I'm
love
not.
this. Very clear and very nice separation here between the topics and the notes, for example. Very nice.
Yes,
Okay.
this makes it easier for me and the audience to understand the logic.
Yeah, love it.
Yeah, so basically, like, yeah, the wall finder program over here, and we are using the service to find the wall. And basically, it is also subscribing to the laser scan topic for the again for the to get the get its present position using the sensors. And from there, we are using the find wall logic again that I mentioned in the previous slide to orient itself perfectly along the wall.
Mm,
And yeah, from there, it uses the command velocity topic to publish the movements. And yeah, so when like the usually the wall finder program starts because in the wall follower it requests the services to start, and that's why I've given a request over here.
mm-hmm.
And once the service is finished, then concurrently the wall following starts over here. And yeah, so I've and this and the wall follower I've already mentioned in the previous slide, the logic behind it. So yeah, I'll go to the next slide.
Great.
Yeah. So yeah, actions, which is the section 3 and the final part of a project, which is actually very important. And basically in actions, we are using the odometry subscription. The node subscribes to the odom topic, updating its internal record of the robot's position whenever a new data arrives. So yeah, so the action server is set up to manage requests to start and stop the record, the robot's lab tracking and odometry data and calculating the total distance. Like as I showed in the real robot, I like the all the geometric positions and as well as the total distance traveled by the robot. And yeah, as the robot moves, as it completes one lap, um, so the logic that I have used is that the starting point and the current point, whenever it is in the proximity of 5 centimeter that is mentioned by the project,
Yeah.
it should automatically stop. But of course, I also encountered some problems with that also.
I should
Uh,
change that to 10 centimeters. Everyone says the
yeah,
same thing.
yeah, exactly.
I
Yeah.
will.
Yeah. So once a lap is detected completed, the lap finish flag is then set to true to indicate that the one lap has been completed. And yeah, from there then the result is sent to the wall follower and it automatically stops. So yeah.
Right.
So yeah, this is again the uh, flow diagram or the algorithm. So yeah, as you can see, this is the action server or the odometry recorder code. And this the action server is called record odometry, which is subscribing to the odom topic. And from here, it gets all the information about its position and total distance traveled and on geometric messages that we receive at the end of the program. And yeah, the wall follower sends the goal to the action package over here. And from here, it continuously sends its feedback to the wall follower. And once the lab detect when the once the lab is over, the result is sent to the wall follower. And from there, the wall following program automatically stops. So yeah, yeah, this is the project. And so yeah, the challenge that I faced is that the biggest challenge that I face is that to make sure the robot stops after it completes one lap. And for some reason, it was not stopping. But then I realized that the 5 centimeter proximity radius is actually too small. Sometimes the
So it's
robot might
not
just
completing. Okay.
yes, sometimes the robot might like overshoot it, or sometimes it might also complete the lap, but it's not exactly like 5 centimeter close to the starting point. So it still continues and does not stop. And
But you
yeah,
return the auction result.
yeah.
Okay. All right.
But yeah, in the action result that I've kept it as zero. I changed it to 0.2,
Oh,
like
I
20.
see. I see. I see.
Yes. So, yes. So from there, it was working correctly. Just increasing the radius. That solved the problem.
Right. Yes, yes.
Yeah.
And you can do that. I mean, it was just a value I came up with. It's not the important part of the
Okay.
project. It's not finishing right where you started. But given out the result once you're done. So that's good. And to force the robot stopping, you can just kill all the nodes. So you can do a
Sure.
shutdown, and that
I
would
mean,
do it.
yeah, but yeah, the point of the project was that it should automatically stop. That's
Absolutely.
even better, right? Because we get all the total distance traveled and the geometric
Yeah,
messages.
yeah. That's true. That's
It's
true.
visually more appealing.
Yeah, yeah.
Yeah. Yeah. So yeah, I think that's it. Like
That's
this
it.
is my
Awesome.
end of
All
my
right.
project.
Well, thank you very much. Do you mind stopping sharing your screen so we can
Yes.
sort of talk face to face here? I have some questions.
Yeah.
Awesome. Yes. Great. Congratulations, Shivesh. That was really nice project. Really, really smooth movement. And I really love your diagrams. I think that is the
Yes.
best way of understanding something, at least for people like me that are very visual in nature, especially for debugging, things like that. Once your
Yes.
system starts getting too hard, think about like even 10 nodes, how difficult it would be to try and debug just with code. So I
Yes.
recommend you keep it up with this practice because it also showcases the nature of ROS2, which is a data-centric system. So you're obtaining the information that you want from the topics, and you have those cylinders as the topics and obtaining the information out. I thought that was great. So I have a couple of questions. So the first one has to do with I see that you have the service to find the wall and the action to record the odometry, right?
Yeah.
So I know this isn't like a question about your project, but I wanted to see how you would think of, like, how could you apply an action to the find wall service? So what else could it give you the implementation of an action as opposed of a service, right? So instead of making a find wall service, making a find wall action. Would that do anything? Would that provide any new functionalities or something like that? What do you think?
Yeah, I mean that's a good question. I think like action is a much better version of service, basically from my understanding. Yeah, and basically like service is basically it gives you only two values, whether it's true or false. And action is a it's divided into three part, which is the goal, the feedback, and the result. So basically with action, we can like curate according, like you can basically curate how you want the so-called find wall service to work.
Exactly.
Um, yes. So over in the code that I've used, basically like the services, we are just using the service, whether the service has started and finished. Basically, that's about it. And with action, we are basically giving the feedback from the odometry package about its position, about the laser scan, and we are publishing it simultaneously to the wall follower. From there, the wall follower is detecting, okay, it has not completed one lap. It is still giving me feedback. And once uh, the lap has been completed, the flag is marked to true, and yeah, from there the wall follower knows that yeah, the action has now sent me the result. So from here, I can stop the program because it has completed one lap, according to my understanding.
No, exactly. Yes. Basically, actions provide you with feedback and the ability of doing other things once you call that server,
Sure.
right?
Yes.
Like, for example, record your odometry. So maybe I'm thinking of previous mistakes. Maybe it happened to you that when you were developing the project, sometimes people, when you're doing the find wall service, the robot starts spinning and it faces the wall and then it keeps going. So you're like, oh my God, I have to wait for another
Yeah.
spin or my service is going to fail. So think about maybe having an action that does the same thing, finds the wall, but maybe provides a feedback. And
Sure.
maybe the feedback changes, you do it so the feedback changes from negative to positive once
Yes.
you switch that.
Exactly.
So now
Yeah.
your feedback is telling you something, so you can take an action based on the feedback. Maybe it's like, well, don't keep spinning, just spin the other way for a little bit and you'll find it quicker. you can add those functionalities. So services are great for
Yes,
just a simple response like taking a picture
of
or
course.
finding this wall, except might be a little complicated because it involves movement and things like that. But we just wanted to showcase the three main components
Yeah,
of ROS
yeah.
2 Basics. All right. I mean, other than that, I don't think I have any more questions just because how clear it was and how well it worked. So, Shivesh, thank you very much for showing us your project and congratulations again.
Yeah, thank you, Rodrigo.
Uh,
And yeah, from here, my next step is to complete the navigations project
All
and to
right.
which,
Well, I'll be here to check it out. It's a little bit
yes,
more complicated, a little bit more configuration, but once you have these two bases, you can make your Roomba at
yeah,
home do anything you want, basically,
yes,
if
yes.
you set it up with a ROS, which would be a nice project. But anyways, thank you very very much, Shivesh. To everyone else that is watching, this is your opportunity to do something like Shivesh has done here in order to obtain one of our certificates of learning. These certificates are very important to us. They mean something to us. So for this, you need to present it and showcase what you've learned, like Shivesh here. So to push your ROS learning, I encourage everyone that is taking our courses to do this and to apply your learnings in a presentation. That's it for all of us. Shivesh, one more time, thank you, and see you in the next NAV2 presentation, I guess.
Thank you. Thank you so much.
All right, guys. Bye-bye. See you next time. All right, cool. We're done. So